Hello, we are in Chapter 6, Section 6.5, Solving Quadratic Inequalities. In this video, we're going to go over problem number 3, in which we are to solve this inequality by graphing. Our inequality already has 0 isolated on the right-hand side, so we can solve the corresponding equation to check for x-intercept. That corresponding equation is x squared minus 49 equals 0, and we can either solve it by factoring, acknowledging that 49 is 7 squared, so we have a difference of squares that is very easy to factor, or we can use the square root principle once we isolate x squared. As I said, factoring here is available, so as the difference of squares, once again, it is x squared minus 7 squared equals 0. So it leads to the difference of squares with the basis of x and 7. So x minus 7, x plus 7 equals 0. And now we use the zero factor property to get x minus 7 equals 0 or x plus 7 equals 0. In the first equation, adding 7 to both sides result in x equals 7. In the second equation, subtracting 7 from both sides result in x equals negative 7. These are our two x-intercepts. Again, what matters the most is which one is further to the left, which one is further to the right on the x-axis. So let's plot them. Now it's the matter of graphing our parabola. We acknowledge that the leading coefficient of our inequality with 0 isolated on the right-hand side is positive 1. Since it's positive, the parabola opens up. So it will look like this with those two x-intercepts. Now we check with the sign of the inequality which part of the parabola we're looking for. And since it says greater than 0, it must be strictly above the x-axis. Since it's a sharp inequality, the parabola should be strictly above the x-axis. Our x-intercepts do not belong to the solution set, because remember that x-intercepts are where our quadratic function has the value of 0, so where it is equal to 0. And this inequality does not include or equal. So the zeros, the solutions to the corresponding equation, do not belong to the solution set. Now, since we are solving for x in this inequality, we have to acknowledge the x intervals, horizontal intervals, in other words, on which the parabola is where we want it to be. That means above the x-axis. And those intervals are highlighted here in red to the left of negative 7, excluding that negative 7, as we said, and to the right of 7, excluding that 7. So at the end, we only care about those x-intervals, and they define our solution set, which in this case is the union of the open intervals from negative infinity to negative 7, and from 7 open again to infinity.